you all in the lecture series of digital electronics, and today's topic is shift register. So we have a name, that is shift register. So it has two function. One is register, that means to store the data, and another operation is shifting, means it stores data with shifting operation. So it is another type of sequential logic circuit in which input and output are connected through feedbacks, can be connected through feedbacks. This sequential device loads the data present on its input and then moves or shift it to its output once every clock cycle. Means in each cycle it will shift the data. A shift register basically consists of several single bits D-type data latches. It means that one D-type flip-flop store one bit, okay, and for storing several single bits we have several D types of data latches. Data bits may be fed in or out of a shift register serially, that is one after the other from either the left or the right direction, or all together at the same time in a parallel configuration. Shift registers are used for data storage or for the movement of data and are therefore commonly used inside calculators, computers to store data such as two binary numbers before they are added together. It means that suppose we have two numbers and we are going to add these two numbers, so before adding operations we have to store that data in some kind of stuff. So that stuff is called register, okay. The individual data latches that make up a single shift register are all driven by a common clock signal, making them synchronous devices. It means in shift registers we have a common clock, and because of that common clock it is called as synchronous devices. Generally we have four types of shift register: serial in, parallel out. It means we have input data. It means we are going to load the data serially, and parallelly we get the output. In the same way we have another types of shift registers like serial in, serial out, parallel in, serial out, parallel in, parallel out. So here is the diagram of serial in, parallel out shift register. So as I told you earlier that for storing number of bits we used in the same number of D flip-flop. So here we are going to storage 4-bit data. So 4-bit data we have to use 4-bit D flip-flop because one D flip-flop store 1 bit, okay. So in this block diagram you can see we have a clock signal at all flip-flops, so these are called synchronous devices. And suppose we are going to apply clock signal at one D flip-flop, okay, D flip-flop, that circuit is called as synchronous circuits. In this diagram it is synchronous circuit. So we are going to take data serially at this flip-flop, and we are going to take data output parallelly, okay. So just see the operation of this shift register. Here you can see that suppose we are going to take input 1, okay. So starting at first clock is your first output will be 1, 0, 0 and 0, okay. Like we are going to see this data movement through a shift register. So at first clock pulse we have a output 1, 0, 0, 0 because we are going to take parallelly output. That's why these bits are not changed. At second clock pulse this will be 0, this will be 1, 0, 0. In the same way we will get parallelly output data. So that's all for today.